Alright, so we're going to finish up chapter 3. Okay. Sometime after this I'm going to probably be posting a review sheet for you guys. So we can get you ready for this next test. Hopefully I'll see some of you guys on Wednesday, or on Monday, Monday on the office hours if you need some extra help, or just again email me any questions you might have. Okay. Last section is 3.5. Okay. This is finding the inverse of a function. Okay. Now we're going to keep this strictly to just linear functions. That's all we need to be able to deal with right now. But when we talk about an inverse, okay, an inverse, okay, is basically the undoing of something. Okay. But to be able to find an inverse of a function, we first have to know what a one-to-one function. Okay. If you remember, we were able to prove something is a function. One way of doing that is by the vertical line test. Okay. So you must first prove that the vertical line test works. And if you notice on these are all functions. Okay, because they pass the vertical line test. Now, what makes something a function is that for every x there's exactly one y. But that doesn't mean you can't have the same y for two different x's. Okay? Because like here, these 2 points would have the same y for two different x's, which is fine. Okay? But to be a one-to-one function, okay, you're going to have for every x, you're going to have exactly one y. And that one y has to go to that same x. Okay? So, how do I test for a one-to-one function? Well, first it has to pass vertical line, and then it also has to pass the horizontal line test. Okay? So, when we look at that, okay, if you look here, horizontal line, this is not one-to-one. Okay? Is this one one-to-one? Well, do a horizontal line and a vertical line test. Passes both of them. Yes, this is a one-to-one. That passes vertical line. Does it pass horizontal line? Yes. So this one also is one-to-one. If it's not a function, like this is not even a function, so then it's not one-to-one. You don't even have to test it. Now, when we do find out an inverse of a function is one-to-one, and it's an inverse, it's still a function, okay, then its inverse, if this is a function, this is the representation for if it is an inverse. So this is inverse notation. Notice the little -1 up here in the exponent area. It's not really an exponent, it's just a symbol, but this makes it says that function is the inverse is a function. Okay, so if a function is one-to-one, then the inverse of the function is also a function. Okay, so if I know a function is one-to-one, like one of these, when I find its inverse, it's going to be a function. When I find the inverse of this one, it's going to be a function. Okay, now how is one way we can find the inverse of a function? Okay, the inverse of a function, we're going to go back up here. The inverse of a function, okay, graphing wise, is you're going to switch the x and the y. So if I have a point 5, -3, the inverse point is -3, 5. You just flip the 2 points, the values. Okay, so anytime we do that, we can find the inverse. Okay, to give you another example to that, okay, if we have a graph, okay, and let's say we have a point here, and we have a point here, and we have a point here. This would be an example oops, let's be way up here, sorry. This is the example of the square root function, okay? That's been transformed, okay? If this point's at 2, 1, this point is at 3, 2, and then 1, 2, 3. I guess it's not really a square root. We'll just call it just a regular function. I didn't put a point in the right spot. So this should be 2, 3, 4, 5. So this is at 5, 3. Now it represents a function. Okay. To find its inverse, we just flip the points. So I'd have 1, 2. We'd have 2, 3. And we'd have 3, 5. And we'd mark those. So we'd have 1, 2, 2, 3, and 3, 5. And so the inverse, we put this little mark here. The inverse of that, okay, is also a function. So notice they both, since this was a function, and it's 1 to 1, then the inverse is also going to be a function. Okay. Now, one of the reasons the inverse does what it does is because it's also known as a reflection over this line. So y is equal to x. You don't really have to know too much about that, but that's kind of how it works. These points reflect over this line this way. Okay. So if you need to find the inverse of a graph, just flip the points and regraph it. Okay. Now, the one thing I need you to also be able to do is to find the inverse of a function algebraically. Okay. Okay, so how I want to do this algebraically, it's pretty simple. It's just basically two steps. I think the book says it's 3. Okay, so our steps are going to be as follows. We're going to first switch our x and y's, and then we're going to solve for y again. So we're just going to do linear functions. That's all we need to be able to deal with. Okay, so in terms of an inverse of this, okay, now this is linear, so it is 1 to 1. Okay, we're going to first switch our x and y's. Now remember, this is y right here. F of x is the same thing as y. So what we're going to do is we're going to switch the x and y. So we're going to have x is equal to 3y minus 5. Notice the x and y's have switched. And we're going to solve for y. Okay, we're going to add add 5 to both sides. That'll give me x plus 5 is equal to 3y. And we're going to divide everything by 3. And we're going to get, now as y is by itself, so we're going to say it's the inverse, is going to equal x plus 5 over 3. And you might see it in some places, they might write it like this, x over 3 plus 5 over 3. Doesn't really matter. Both the same. And that's basically the only type of inverse we're going to make you deal with. It's linear, and this is another line basically. Okay. Now, one thing is not on the test, but it is on your homework. So I want you to see it's not real difficult, and it's something you can actually work through it. It says to verify functions are inverses of each other, you use a composition. That's what the last session was. So just a little practice with it. It says if you find f of g of x, okay, and it equals x, and g of f of x also equals x, then the two functions are inverses of each other. Well, I know this. I know f of x. If I say f of x is 3x minus 5, okay, and now we say that g of x is what we just found out a second ago, x plus 5 over 3. We know those are inverses, but let's prove that they're inverses. Okay? So, we're going to say this is f of x, this is g of x. So we're going to put g of x into f of x. So if f of x is 3 times x minus 5, and we put x plus 5 over 3 in there, let's see what happens. We're going to distribute. Well, when I distribute these two, all I'm left to, the 3's cancel. X plus 5 minus 5. Now, wouldn't these two cancel each other? Which gives me x. And that's what we want. We want the f of g of x to equal x. Well, that worked. But if you remember on 3.4, f of g of x is not always the same as g of f of x. So now what we have to do is take the g function, x plus 5 over 3, put the f function inside the parentheses, and simplify. Well, here the 5's would cancel, which gives me 3x over 3. Then the 3's cancel, which gives me x. So, because f of g of x equals x, and g of f of x also equals x, then these two functions are what we would say that they are inverses. And that's how you prove that the two are inverses. And that's part of a problem on your homework. Actually, it's on the quiz, but that part of the quiz, or on the test, but that part of the test is actually going to be extra credit for you, just because it's kind of a quick little thing. Okay, so if you can get that on the test, you're going to get some extra credit. Alright, so hopefully this helps you with your 3.5.